So this standard is all about finding different properties of rational functions. Okay. The first one we always do is domain. What is domain?
Domain, isn't that the
X values. Yep. Okay. So it's values that you can plug in for X that you will get an answer for Y. Okay. For the most part, it's going to be about any number in the world. But when you have a rational function, okay, there's definitely some numbers that won't work. Okay. And it would be numbers that make what?
the top equals 0?
Can the top of a fraction equal 0?
Yeah.
Yeah, isn't 0 divided by 8 0?
Yeah.
That's an answer, right? What about 8 divided by 0?
Um,
That's not an answer, right? So we can't have the denominator equal 0. So whatever x values make your denominator equal 0, those x values are not part of your domain. The domain is only x values that you can actually substitute in for x, and it'll give you a real answer for y. Okay? Now the best way to see that is usually to factor everything.
and then that would be 5x plus 2x minus 2.
Okay, so now looking at that, I can tell you what numbers are not in my domain.
Negative 2.
Negative 2 and
Negative 4.
negative 4. So my domain is every number except negative 2 and negative 4. And that's how we write it. Every number from negative infinity to negative 4, every number from negative 4 to negative 2, every number from negative 2 to positive infinity, but it does not include negative 4, you can tell, because I'm not using what sort of grouping symbols?
Bracket.
The square brackets, yep. If I use square brackets, then it actually means that equal to negative 4 or equal to negative 2, but this just means right up to, but not including negative 4. Starting just past negative 4 all the way up to, but not including negative 2, and so on. Okay? So there's my domain. As long as we're on domain, let's talk about vertical asymptotes. Where do vertical asymptotes happen?
And then the x-axis.
Well, they happen at some x value,
When x equals 0.
whatever x value makes just the denominator equal 0. So like as the denominator gets really close to 0, and only the denominator. Now here, negative 2 makes both the top and the bottom equal 0. That's not going to be a vertical asymptote, because those are essentially going to cancel out.
Negative 4.
At negative 4, I'm going to have a vertical asymptote. Okay? So you might want to write that down. How do you know where vertical asymptotes occur? Well, vertical asymptotes occur at whatever x values make only the denominator equal 0. Yes, no, vertical asymptote?
Yep.
Holes occur at the x values that make both the top and the bottom equal 0. So in that case, that would have been what?
The
X value.
negative 2.
Yeah. And holes are actually coordinates. Okay, they're not vertical lines. Like vertical asymptotes are imaginary vertical lines that the graphs get really, really close to but never touch. Holes are actually coordinates that the graphs chugging along, well, not defined, and then it keeps going. Okay, that's a hole. Alright, we've talked about those before. But you're like, okay, well, a hole is not defined. Obviously, negative 2 is not part of my domain, so how can I actually figure out the y value where it is?
Plug it in.
Okay, plug it in after you cancel the common factors. Right? So negative 2 minus 2 is negative 4 times
Negative 20
negative 5.
Negative 20 over 2.
Negative 20 over 2, so negative.
Be
10.
negative 10.
Right? Okay? So any questions on finding out where the holes occur? Okay? Let's see. Let's go horizontal asymptotes. Horizontal asymptotes, remember, are what graphs are doing way at the far ends of the graph. So it usually means the graph is, approaching It's leveling off, okay?
Don't use Desmos.
Use Desmos for that, okay? I'm gonna speed up the process here because I'm videoing this thing right now. You can double check it in a moment, okay? But this one's gonna have a vertical asymptote at 5, excuse me, a horizontal asymptote at y equals 5, okay? So y equals 5 is gonna be our horizontal asymptote. Well, that means the graph doesn't touch a y value of 5, right?
Yeah.
Okay, but it touches every other y value. So what is my range?
Negative infinity to 5, u 5 to negative, or 5 to positive
Yeah.
infinity.
And again, you're looking at Desmos for both of those answers, okay?
Okay.
But I'm gonna trust you can enter that, and we'll do that after the video's done. I'm just doing it for time purposes, I'm gonna keep rolling, okay? All right, and the last two are pretty simple, x-intercepts and y-intercepts. Okay? Y-intercepts are the easiest one. Where does a graph cross the y-axis? Well, whatever y value it hits when x is what number?
0.
When x is 0. So you know this is always going to be 0 comma something. And this one's going to be something comma 0, right? Okay? Well, this one's the easy part. If you know the x value is 0, how can you figure out the y value? Plug it in. Plug in a 0, plug in a 0, plug in a 0. I get negative 20 over 8, which is negative 10 over 4, which is negative 5 over 2, or negative 2.5. I like fractions, so I'm going to do negative 5 over 2. Went fast there, but okay. All right. Now the other way around, a little bit more difficult, but all I know is that this has to equal 0. Well, the only way a fraction is equal to 0 is at the top equals a 0, right? Well, I canceled these off, so now I really have 5 times x minus 2 all over x plus 4.
X equals 2.
Yeah. I mean, you can see that, but if you wanted to show some work, it'd be pretty easy. So you know that this has to equal 0, right?
Yeah.
Multiply both sides by x plus 4,
Which still gives you 0.
which still gives you 0. Divide both sides by
5.
5, which again still gives you 0. And add 2, and you get 2. So there's my work, there's my x-intercept, and I'm done. So, real quick example of how to find these 7 properties without doing a whole lot of work. You use Desmos for these. I taught you another way to do it, but for the speed of the video, I'm just going to refer you back to Desmos. Okay?
Alrighty, thank you. I'm
Yep.
gonna do a few.